Good evening. My name is Mr. Barris, and I'm going to take you through how to simplify and evaluate exponential notation tonight. I'm doing this at the request of one of my students who texted me this evening and said that he was having difficulty with these types of problems. So if you're watching, this one's for you. Without further ado, let's start the screen share, and we will see exactly what we're dealing with. Okay, so let's go ahead and just give you an example of what exponential notation might look like on, say, a homework problem. They could give you something that looks like this. X squared y cubed over x to the -1, y to the -1, okay? You know this is an exponential notation because you've got a whole bunch of exponents on different items inside this problem. So this needs to be simplified, but how? Well, if you're familiar with exponents, exponents is just another way of saying a number times itself a certain number of times. So for example, let's take this x squared term and expand it. This little squared symbol up here means that we're going to be taking this x and timesing itself 2 times, okay? So we have x being times by itself 2 times, and then we have y being times by itself 3 times. You'll notice I just times both of these expressions together because they're adjacent to each other in the original problem. Okay. Now the denominators can be a little bit more difficult because you can't really imagine timesing x by itself -1 times. So here comes an important property in exponents. Whenever you have a variable or a number raised to a negative exponent, the easiest way to fix that is just take that negative exponent, make it positive, and bring it up to the opposite side. That being either the top or the bottom. So for example, if I've got x to the -1, which I had originally down here, then I need to automatically know that I'm going to make it positive and bring this whole thing up to the top. Okay, so now I've got this extra x up here. Okay. Similarly, if we've got y to the -1 power, I just got to automatically know to make it positive and bring it up here to the top. So here I have another extra y to the first power. Okay. So you can see that after we simplified it, we've got a whole bunch of x's and a whole bunch of y's in the numerator of our problem. Now, using another property of exponents, if we've got the same base, namely the big number right here, see all these bases are x. If we've got the same base being multiplied by itself, we can just add up the exponents. Okay, so for example, imagine that we've got a whole bunch of x's raised to the first power up here. Because they're all being times used by each other, when we're simplifying this, we can just say x to the 3rd power because we have 1, 2, 3 of them. And that's a property of exponents, and we can do that. Similarly, we have a whole bunch of y's, which are all the same base being times by each other, meaning that we can add all their exponents. 1, 2, 3, 4. Okay? That is totally simplified. There's nothing really else that we can do with that. Let's practice this again. That was an example problem. And let's see if we can point out a couple shortcuts that we can take. So let's say I have x to the -5, y to the 1st, over x cubed y to the -7. Okay? So once again, we'll deal with the negatives just by flipping the sign and taking the whole thing, bringing it to the opposite side. So I brought that x to the -5th down to the bottom and made it positive. Similarly, I have this y to the -7th down here in the denominator. So I'm going to automatically make it positive and move that whole thing up here. Okay? So when we do those 2 things, we end up with y to the 1st times y to the 7th over x to the 3rd times x to the 5th. Okay. And now we can see how these things will simplify. So once again, the rule we're going to use now, because we have the same base right here, when we're simplifying, we can add the exponents up. Okay, so we're going to have our common base, and the exponent is just going to be 1 plus 7, so y to the 8th. And down below, we're going to have x to the 3rd times x to the 5th, same base, so we can just add those up, x to the 8th. Okay, there is our problem simplified as completely as it can be. Okay, now just in case you're looking for a shortcut, or if this just isn't quite clicking for you, let me show you another way to approach this problem. So let's say I'm dealing with the original problem, x to the negative 5th, y to the 1st, over x to the 3rd, y to the negative 7th. Okay. If you like what I'm about to show you, stick with it. If not, use the first method I showed you. So you'll notice we have x's on the top and the bottom. Okay. So whenever you have x's on the top or the bottom, or any variable on the top or the bottom, and whenever those variables have exponents attached to them, automatically look for the larger of the two exponents. So for example, 3 is definitely bigger than negative 5. Okay. So now that I've found the larger of the two exponents, what I'm going to do, because the larger exponent is found on the bottom, I know that my variable is going to end up on the bottom. Okay. Now, question is, what is the exponent going to be? Well, what I need to do is take the larger of the two exponents minus the smaller of the two exponents. Okay. Similarly, with the y's, I've got one on the top, one on the bottom. I'm going to take the larger of the two. So positive 1 is definitely larger than negative 7. So I know that my y's are going to be on top, since y to the 1st was on the top. And similarly, I'm going to take the larger of the two, subtract away the smaller of the two. Okay. And now you can see we can do some simplifying, because 1 minus a negative 7 is going to be y to the 8th power. And 3 minus a negative 5 is the same thing as adding 5 to 3. So we're going to have x to the 8th as well. And you can see these two answers are exactly the same. Okay, so either method should work. And it's basically the exact same method, just shown to you differently. Let's finish off the night with something a little bit more tricky, so we can hopefully get this solid in our minds. So let's do something with like 3 variables. So let's say I had x to the 10th, y to the negative 2nd, z to the 3rd, over x to the 5th, y to the negative 2nd, z to the negative 4th. And let's say I add in some numbers. Let's say 6 to the negative 3rd and 2 squared. Okay. Looks really tricky, but using the simple steps I've showed you within the past 10 minutes or so, we can make this very easy to do. Okay, so we're just going to run through this one by one. Let's deal with these constants first. I call them constants because they don't have any variables involved. You'll notice that this 6 has a negative exponent attached to it. So right off the bat, I know that with negative exponents, I just make them positive and move it to the bottom. Okay. This 2 does not have a negative exponent, so it's okay to be left where it is. Okay. So if I wanted to rewrite this, we could rewrite it with that change being made. So I moved my 6 to the 3rd to the bottom. My 2 squareds still there. X to the 5th, y to the negative 2nd, z to the negative 4th. Okay. And I could evaluate these two things right now if I wanted to. So for example, 6 to the 3rd power, well, 6 squared is 36. 36 times 6. Let's see here. 36 times 6. 216. Okay. So I've got this. I'm just going to erase and insert that in here. This is 216. And 2 squared is 4. Okay. Now let's figure out what 216 times 4 is. Okay, it looks like it's 864. So I know that my denominator, I'm going to have 864. My numerator, nothing's really changed yet. It hasn't really changed yet. Now let's focus on the variables. So we're going to follow the same rule as the second method that I showed you up above. That is, we are going to take the larger of the two exponents for each variable, subtract the smaller one, and leave it in the position where the larger one was. So for example, x to the 10th, 10 is obviously much larger than the 5th. So I'm going to take my x to the 10 minus 5 power. I'm going to leave it up top since that's where my larger exponent was. If you look at your y's, we have y to the negative second, y to the negative second on the top and the bottom. Well, neither of those is very large, or larger than the other, I should say, but they're the exact same thing. So in math, whenever you have the exact same thing on the numerator and the denominator, they can just cancel out. Okay, my y's are totally gone. And then the last, looking at z's, the exponent of 3 is definitely larger than the exponent of negative 4. Okay, so we have z to the 3 minus 4, and then down at the bottom I still have my 864. And then to finish this thing up, x to the 10 minus 5, well 10 minus 5 is just 5. Z to the 3 minus 4, well 3 minus 4 is just negative 1. And then over 864. Now some math books would like you to eliminate all negative variables, or negative exponents, excuse me. So we could just take this z to the negative 1, make it positive 1, move the whole thing down. And so our final answer would be x to the 5th over 864 z to the first power. Or I'll just leave it as z, since the first power is kind of implied. Okay, that is your crash course on exponential notation. I hope that helps. We will see you next time.